thank you for being here. If you are here, it's because I heckled you to come, and thank you for actually coming. Or maybe you have some interest in DevOps, CI/CD pipelines. It worked out really well this morning that the keynote was about DevOps, and the guy giving the presentation, Justin, did an awesome job. But I was like, how am I going to top that? It's the keynote. Well, we're gonna try to do our best and see if we can learn something new here together, or at the very least, just see some cool open source software and some more ASCII art cows. So, a little bit about myself. My name is Lucas Ward. I work for a consulting agency called EPON Technologies. EPON is all about positive technology. I'm a proud father of 2 little gremlins, a loving husband, and a absolutely insane mad scientist. So this picture of me here on the right is, if you recognize the full anti-static garb of a circuit board manufacturing place. Really cool thing to go check out. If you've ever gone, you can tour them. They're usually open for tours. I started off my professional journey in the restaurant industry. I spent 10 years working, flipping burgers and making food, and put enough time in to know that that is not what I wanted to do for my life. A really awesome guy named Chad Lingefelt gave me a break and let me come in and do some systems design for a locksmith company. Now, if you've ever worked with locksmiths, they are some very interesting people, but is a underserved community when it comes to software. From there, I went and did some IoT work in the DevOps space, which is an interesting combination of challenges. And now I work for EPON. So here's the logo on the screen. And that's the last sales pitchy bit that I'll give you, and we're going to jump right into this. So this presentation, with its OpenAI ChatGPT generated clickbait title, Revolutionize Your Deployment Pipelines with the Power of GitOps, is actually all about Kubernetes. Who has heard of Kubernetes before? Raise your hand. All right, keep your hands up if you absolutely hate Kubernetes. Okay, more or less. It's getting better, I guess. Kubernetes, when it first came out, was a extremely hot buzzword. Turned out to be a little bit more than a buzzword, and is actually a really awesome abstraction on how to orchestrate containers and to run your operations. A couple years ago, even, it was a little bit of the Wild West, where multiple companies and patterns, everybody's trying to figure out the best way to do things. To build a platform, for instance, like in the keynote this morning they talked about. The thing is there's a lot of tools out there. And this is a developer conference, so you may be familiar with the tools you have on your local machine to write code, build software, test it. But there may be some things on the other side of the quote-unquote wall that you haven't seen yet. So my hope is to show you some cool stuff. Most of my demo is going to be live coding and on the internet, so pray that the Wi-Fi doesn't get choked out. So, in order to understand why we have things like DevOps and CI/CD pipelines and GitOps, it's important to build some base knowledge. So, in order to understand GitOps, we have to know how software is deployed into not just old and new systems, but also how old software can be deployed into new systems. For instance, a Power Builder application that's been containerized and Frankensteined into a Kubernetes cluster. But in order to understand DevOps and GitOps, we also need to understand continuous integration, which is basically the DevOps promise to allow you to deliver software faster. But what is DevOps even supposed to serve? And as developers, you should be very familiar with the third one here, the software development lifecycle. So I'm not going to spend too much time on this slide because I'm sure you've seen it before, but the general premise is someone has an idea to build something, they probably start writing code immediately, maybe they do some design work, and then they build this awesome thing, they show it to their boss, and they're like, great, let's put it into production, and then it's another 2 or 3 months trying to figure out how to do that part. That part can actually be take longer than building the application. Quick sidebar, when I was first entering this field, I was a software developer. And a lot of people come into DevOps from the operations side. I did it the opposite way, so don't ask me about networking because I don't know. But one of the things that I realized is we had built an application for these locksmiths, and it was time to put it out there for the world. And so I started on the process like, well, okay, I know we need a server. So, AWS, I need a server. Okay, DigitalOcean, Lightsail, Heroku, all these things. And throughout that process, it just became more and more and more pieces. And suddenly I'm reading about Lambda and functions as a service and just totally overwhelmed. But I did find that I really enjoyed that piece. So if you are a developer that normally hands your code off or just commits it and walks away, I encourage you to check out what happens after that code goes to the repo and enters, cloud or data center or wherever it may want. We all saw this morning, so I won't spend too much time here, but the DevOps is essentially the combining of developers and operations trying to break down barriers, trying to handshake and talk and hang out and not have this culture of, well, you built it wrong and now it won't run, or I built it. I can't figure out how to run it because I don't understand JavaScript. And this next slide is going to have some blanket statements, and some of you may be triggered by some of these statements, but the problem here is humans. We are the problem with software and why it is so difficult to sometimes build and deploy it. So here's some stereotypes you may have heard: throwing the code over the wall, developers not knowing about servers and artifact repositories, or whatever came before that, operation engineers throwing it back and saying, whatever this transitive dependency you've introduced won't allow it to compile on my server, and a whole bunch of nothing burger, like lots of software engineers don't write tests for their code. Not saying any of you do that. Hopefully everyone is doing testing. It's a good thing to do. A lot of software developers don't understand CPU architecture and compilers. And if you ask them about, hey, what execution environment is this meant to run in, they'll just say, well, it works on my laptop. Now, this is less true today than it has been in the past, but you get the point. So we have thankfully evolved into a new layer of stereotypes where software engineers write secure code that's reviewed by peers and it follows best practices. And we follow that SDLC, that diagram. Like a lot of times a new idea comes down and there's whole teams of people now called product engineers and product managers that will help you design your feature, your application before you write any code. This is a good thing. Also, they hang out and talk. I am a DevOps engineer at a developer conference, and I've been talking to a lot of you. Some of you I've heckled into coming here. And it's a big difference from kind of the old guard and the new and the two different sides of the wall. Things are getting more melded and mushed together. And to hear Justin say it this morning, about more workload coming on to the developers, that can be true, but it is important to understand where and how your application runs, because certain types of applications may run better or worse on different types of CPU architectures. Some things that are containerized shouldn't be, and some things that are built into Lambda shouldn't be, like a Django application, for instance. I've seen that. And yeah, so a lot of the operations engineers that used to manage the data center, instead they're now managing YAML files and deployment pipelines. And it's up to them whether they're happy or sad about that. But I think in general, DevOps has brought the two sides much closer together. And the reason we automate everything is to actually remove that human element that causes issues. For instance, pulling your dependencies from different places, or configuring the server wrong, or someone SSHing into a server and just doing some type of magical bit of code that makes it happy. And so we've done this and we've iterated on it over and over and again. We've done our agile practices on top of our DevOps practices. And we've got all of this automation allows us to deploy software tens or hundreds or thousands of times a day across huge teams, also that somebody at a conference can generate some ASCII art cows. Undefined? What? Okay, there we go. Interesting, yes. So very cool stuff. OpenFast is a open function as a service platform. It's basically Lambda that runs in your Kubernetes cluster. It's open source. They do have a paid thing, but you can generate cows on your home lab setup too. Okay, I promise just to do a few more cow slug. So, why did we get to this point of high levels of automation? Where was the driving factors and principles? Developers went from using horrible version control stuff to things like SVN, and then finally to Git. And just the amount of automation and amount of kind of quality of life improvements that they experienced were astounding. And I think DevOps and operations people got a bit jealous, and so they decided they were going to go out and automate everything too. They wanted to push their infrastructure code to a repo. They wanted to have build pipelines to build their infrastructure. And now we've done that. And a lot of times, if you are a software developer that has been living in a deployment pipeline type of landscape, it's not too much of a jump to go and say, hey, instead of writing application code, I'm writing infrastructure as code, and it's deployed through a pipeline in the same way. So it is in your best interest to understand these different pieces and to not just say, oh, my responsibility stops here and it's the other person's problem, because it's better when we all work together. All right, so I'm gonna demo a couple tools. Call this the tools of the trade. Justin this morning showed the huge CNCF landscape of thousands of tools. But ultimately, when you go to build a deployment pipeline or a GitOps workflow, you have to make some choices. And so I've picked some tools here. We've got Git. Everyone here should be familiar with Git. If you're not, then go figure that piece out. Helm is a package manager. So it's like pip or npm, but for software, containerized software applications. Argo CD is a continuous deployment declarative thing that will basically say, hey, I'm looking at this Git repo here where you've got all of these YAML files, and I have access to this server over here. Let me bring it all together and make it happen. And declarative definitions are a beautiful thing. You just tell it how you want it to be always, and if there's some issue, it'll start trying to get it back to that desired state. We mentioned Kubernetes before. Kubernetes is a huge container orchestration platform. Quick aside about Kubernetes. So many of you probably remember when the cloud was first becoming a thing, right? It used to be you have a server in a data center or in your closet, and then suddenly you had the ability to spin a server up on the internet, right? And access it as you would if it was in your closet. And after the cloud providers, especially the big three, got that part kind of figured out, they said, well, what if we take the database and put it on its own server? What if we take the API and put things in front of it? What if we separate everything into its own individual service so we can extract as much profit as humanly possible? They did this. And then finally they said, you know what? Let's take this thing that we've built, this cloud orchestration abstraction, and let's turn it into an open source product. And hence Kubernetes was born. Kubernetes is essentially the backbone of a cloud. And the crazy thing is we came full circle where you can now run Kubernetes, which can essentially be a cloud, on a single server in your closet, which is where this is running. It's not in my closet, but it's on a single server out in Texas somewhere. Kubernetes is a really beautiful thing. It has a steep learning curve, but the more you know about it, the more you can reason about better ways to design microservices and make them talk to each other and how to deploy things. Most of you are probably familiar with Prometheus and Grafana. These are observability tools. Site reliability engineers love these tools. They provide insight into your applications, things like traces, latency. You can see your logs there as well and get those cool like word cloud things that you see that are maybe not that useful, but they look really cool. Anything that has a colorful UI, I'm here for it. So, all right, we're gonna go through a demo. There's a little bit of back and forth here on my screen, so if you get motion sickness, I'm really sorry. But we're gonna start with Git, excuse me. So Git is the root of all of your GitOps workflows. I mean, it makes sense, it's in the name. And I'm gonna demo here to you a folder structure of how you can do a GitOps workflow and have a cohesive microsystems ecosystem. So I've got one folder here, Lucas Engineering. This is my charts for Argo CD. Charts are just Helm charts, which are pieces of software. And then I've got a finance app of microservices here. Each one of these folders is its own Git repo. It's important when you're going to build a microservices architecture ecosystem to understand early as possible what your Git strategy is going to be. Is it going to be one big repo? Is it going to be each application has its own repo? Maybe those are submodules. There's lots of decisions there, and they do have an impact on how that workflow will be ran and how you'll be able to interact with it. So for this demo, I've put these charts together in a pattern for Argo CD that's called App of Apps. And we'll see a little bit more of that here in a second. But Argo CD code goes into its own repo, and the applications each get their own folder. And if you remember, Argo CD just looks at the repo and says, hey, there's some change here, let's go over here and make it execute. All right, Helm, when you boil it down to how do I interact and work with Helm, there's two core pieces. A Helm chart, which is yet another YAML file, and a values file. The chart essentially is what version of this, what name, what is any metadata I want to connect to it, And the values file is going to be configurations. You can put things like environment variables in there or what port you want to expose and this type of thing. And so Helm is a really cool tool. When I was showing you my repo here, we've got this folder called charts. And most of these folders have a chart and a values file. So for Prometheus, for instance, we have a chart. It says what API version, what's the name, where does the chart live, and then the values file say what port, what type of ingress do we want to have. So lots of network DevOps operations things, but it's all encapsulated here in code. If you remember, one of my first slides says codify everything, and you'll see that throughout this presentation, we don't make a change to our infrastructure or deployment or our application unless it goes through a repo. That's the whole point of GitOps. All right, how many people have used Helm before? Just curious, show of hands. Okay, good. So it's not totally just talking to the wall here. All right, the next piece of technology we're gonna look at is called Argo CD. I'm a sucker for some really beautiful UI work, and so I think Argo CD has done a fantastic job. You remember all those folders I was just showing you with the charts? Each one of those folders corresponds to a little box here that says, hey, this is the application, it's healthy, we can click on this, and yes, I am running a database in the cluster. And we can see all the different pieces that have been deployed by this Helm chart. So this is something that if you were maybe 10 years ago, you'd have to go in and set up manually or run some scripts or use some tooling to deploy. All I did was just stick the chart into my thing, and it deployed all of this. It's highly opinionated, but with that values file, you can overwrite your opinions and stuff. And I can even come in here and click on the pod and see logs right here in Argo CD. So a really fantastic tool. And we're gonna come back to it here in a second. In a little bit, we're gonna deploy a new piece of software into this, this cluster. So that's Argo CD. They got a cute little logo as well. All right, the next one is Kubernetes. We talked a little bit about Kubernetes, but most people, when they talk about Kubernetes, they just are talking theory and kind of what it is and how it works and stuff. But I have a tool here I want to show you that actually provides a wonderful visual. If you're a ClickOps type of person or you like to have a UI to understand what you're doing, this tool called OpenLens, which is also an open source tool, does a really awesome job. If you've ever been into AWS EKS or Azure into their container services, you might recognize some of these things like I can see my pods and my deployments, and there's loads of pods here. And they have this really cool thing called a resource map. So this is all of the logical bits of my Kubernetes cluster, which includes the ASCII art cow generator, a couple Python microservices I made to scrape Yahoo Finance, and also some observability stack. So you get this really cool thing, and if you click and drag on it, it makes everything jiggle around, which I find to be a lot of fun. All right. And from here, we can delete pods, we can see logs, we can make changes to the cluster. Ideally, that stuff happens through your Git repo, though, and you're just here to look at it. All right. And if you're interested in using Docker and Kubernetes, I highly recommend a tool called Rancher Desktop. It's an open source tool. When you install Rancher Desktop, it will install a Docker daemon on your local machine for you. And it's a great way to get Docker without going down the Docker desktop route, which you may run into licensing issues if you go that way, especially if you're using it for your work. So Rancher Desktop, shout out for them. And it can run in production too. It's not just for development. You can run it on your local machine. You can install Rancher on servers in the data center, wherever you'd like to use it. All right, so the next piece is gonna be Prometheus and Grafana. You'll rarely see these two without the other. They kind of go hand in hand. Prometheus is going to aid in the extraction and export of your log files from your various services and other metrics as well. And then Grafana is gonna help you to visualize those. So if I come over here, back to my web browser, get a quick cow generated in here, and we look at Grafana. So I'm gonna come back to this screen here in a second, but we have dashboards here that can show us all of our underlying nodes. There's loads of panels here that I won't bore you with, but it's charts and graphs. It's a way to observe your application. If you're in the SRE field, you may have some observability type of dashboards here where you can see latency per endpoint, percent 500 requests. And I actually have a demo here we're gonna have an endpoint that gives me a 500. Let's get a couple of those here. So this is just a Swagger API. This is that hitting Yahoo Finance thing I was telling you about. Let's hit it a few times. We're getting a history of Microsoft stock here. And then when we come back to our observability dashboard, it takes a couple seconds for it to scrape those metrics and put them on here. But you'll see that the dashboard is responding to those calls. And so if you've done any observability work, you know that latency and metrics and log files are all part of these 3 pillars of observability. They can help you catch problems before you have the problems. And it's really powerful tools. We'll come back here and see if it updates. It can be a little bit of time sometimes for it to scrape the metrics. Okay, so we're gonna put it all together now into a demo of the GitOps workflow. How many of you in here have heard of WordPress? Okay, it's often used, much hated. Everybody knows about WordPress. If you're a developer, you probably don't develop for WordPress unless you make plugins or something, but it's written in PHP. Say again? I'm sorry. Oh, no. No, it's okay. WordPress is great, and PHP is actually a fantastic language. You can go really, really far with your business just using WordPress, and they have amazing self-hosted options. So, all right, we're going to go back over here to our repo, and you see our latency metrics have appeared. We got a couple increase here in our %500s, and we're going to jump over to our Git repo. So this is where the magic happens. I've got a couple pre-prepared files here because I don't want to bore you typing on the screen, but let's say you decide that you want to self-host WordPress for businesses in your hometown. You might deploy a cluster such as this, and then anytime you bring on a new customer, you may wish to deploy a new WordPress site with its own subdomain and things. So that's what we're gonna do. We're gonna pretend that we are in the business of hosting WordPress. So I'm gonna open up my charts folder here. We have this root app folder here. This is a Argo CD pattern called app of apps. When I expand this template file, you'll see all of those services I was just showing you each have their own YAML file here. And we're gonna just add a new file. We'll call it wordpress.yaml. And then I'm gonna do some copy pasta from down here. And essentially, this is just the metadata. It says, what repo are we looking at? What container image do we want? What service are we going to deploy this to? And this is, I didn't change anything from the defaults here. So this is not any type of rocket science. If you go to, I'm sorry, you have a question? Yes. It's going to get really, really big. We don't need the terminal right now. Okay, can everybody see that okay? Fantastic. So we added our WordPress file. We're now going to come down and we're going to add a new folder as well. So here in our charts folder, we need a new folder for WordPress. We'll call it WordPress. And then you remember when we talked about Helm, we needed a chart file and a values file. So we'll make one here, chart.yaml. And then we'll make another one, values.yaml. And if you go to like a Bitnami or any other site where you can find containerized workloads, they will give you these files, okay? This is not something that I had to go and write these files. I just have them here for ease of access. But this is all stuff you can do on your local machine, in your home lab, wherever you like to deploy stuff. So we got WordPress. It's coming from the Bitnami charts registry, which is basically just a Docker registry. Bitnami, they offer opinionated versions of charts for applications. So for instance, my Postgres is running off a Bitnami chart, and they provide a bunch of default values for me that will keep it going for some time. In fact, this cluster here, the Postgres database here has been running for 373 days. So fairly stable. Definitely some companies I've worked for, have not made it that long without having some type of outage. Mind you, all I'm doing is scraping Yahoo Finance. Anyway, so now let's get our values file here. You can see in my values file, I am specifying a password called really bad password, as well as a load balancer with these ports being exposed. So we'll come over and paste that, and we'll save it, because I always forget to press save when I do this demo, and then it doesn't work. Okay. Now we need our terminal back. We're in this folder here, Lucas Engineering. We're going to say git status. So this is where the git part of the GitOps workflow comes, right? Everyone's used Git. I'm assuming that everyone's used Git. We're just going to add our new files here. So git add -a. We'll say git status again so we can see the green stuff instead of the red. We've got all 3 files here. We'll say git commit new WordPress. And then we're going to push it. And once we push it, We can go over to Argo CD, which is what we use for our continuous deployment. So we've put code up, and now we want to deploy it into our Kubernetes cluster. And Argo CD can be configured to ping those repos on a schedule, so like every 2 minutes or 3 minutes or 6 hours or whatever, and it's just like, hey, you got any changes yet? Hey, you got any changes yet? Me being the impatient person that I am, I'm just gonna come here to our root app and press refresh. And what it's gonna do is it's gonna pop up a new box here, WordPress. It's gonna take a second, but look at all of these resources it's deploying. Persistent volumes, we've got some secrets, we've got the pods, we've got ingresses, load balancers, all of it with just a push to a repo. So very powerful. If you're selling WordPress to people or any other piece of software where you have a siloed tenant isolation policy, you just come here and you add a new thing, you give them a subdomain, and all of their stuff spun up. So that's talk about automating the onboarding process, right? And you can build platforms on top of this, like what Justin was talking about this morning, put additional UI pieces surrounding these tools. But everything I've shown you thus far is 100% open source, and you can build this on your own. We're gonna give the pod a little bit of time to start up here. We can see the logs. Trying to connect to the database, we can come over to our database pod, which is running MariaDB, see the logs here. Looks like it's throwing a couple warnings, but it's happy enough. Database is up. Come back and look at our pod logs. Starting Apache, it's still doing its thing. Okay, we got a 200. So now we should be able to come up here and say WordPress.lucas.engineering. And look at that, we have our WordPress site. And we can even come in and say /admin. And now we're gonna use user@example.com and the really bad password you saw in the values file. Just check, really bad password. We'll log in, and now we're in our PHP admin backend. So we're off to the races. We could add users into our values file to hand off to the client that's gonna be, I don't know, building their business site, or maybe we have a team of people that does that instead. But the whole point of this demo is to show you that if you take the time up front to build out the tooling and the different pieces of this, you can provide a platform where people can come in and they can deploy their software. And depending on your different levels of permission and access and your developer skill sets, you can actually give them access to pieces of these. So I could have a login to Argo CD that allows me to see the applications that I'm a parent for. Or maybe you don't want the developers to have extra permissions and responsibilities, and you just say, hey, when you push it up to the repo, I'll take care of that part after that. But there's no longer this process of where is this running, how is it running, because when they were building the application locally on their machine, they did it in a container. And I just took that container and put it over there. It doesn't matter if my cluster runs on ARM CPU architecture and yours runs on something different, AMD 64. It may matter if there's different packages that aren't supported, but that's why we have things like package repositories and dependency management platforms. All right, let's see. I went a little bit faster than I meant to. I drank too much Red Bull. So we're gonna just generate a couple more cows here real quick. Thomas Edison cow, that's hilarious. So I was giving this demo once, and I did the cow thing, and I just thought it was cute to have ASCII art cows. And there was a what people might call an old beard or a grayed beard, and they thought the cow thing was awesome. I said, what's so cool about that? And apparently, way back when, and this is just something random that the person told me, I don't know if it's true or not, but they said one of the ways they would make sure their servers were up is they would use a lightweight program, oftentimes just generating cow ASCII art that would print out into the console. So this is coming full circle all the way back to a serverless function as a service platform generating the cows to make sure that we're up and running good. All right, now I want to show you one more thing. So you might say, okay, this is all well and good, very cool, you know, we deployed WordPress, but what about other applications? What about applications that run with different backends? What about applications like written in Python or Java or Go? You know, how does the level of complexity change when I'm not just getting a Bitnami chart? So we're gonna take a quick look at the Yahoo Finance scraper. Maybe we'll get rate limited by Yahoo Finance. I don't know, we'll have to wait and see. But let me pull up my repos here. Ginormous font that I still can't see fully. So I have 3 Python microservices here. They are very simple Python services. They just have, API, a database file, some models, just as simple as it goes to build a fast API, REST API. I've got one that lives in front of the web scraper, so it talks to Yahoo Finance and exposes endpoints to do that. And then I have one that lives in front of the database. It talks to the database, and then I've got one in the middle called the Scraper Manager that will go and it'll check on Yahoo Finance and say, do we have additional lines that we want to pull? And this was going to inevitably turn into a stock market trading game where you could pick a time frame and say, okay, I want to invest between the 1970s and the 1980s. And throughout that time period, maybe it'll play out over 10 days, see who can win, see who knows their history and the impact on the stock market that it had. All right, so if we take a look here at our fast API, we can see here that we have a history endpoint. And Yahoo, for some reason, after all these years, still keeps this up, and you can pull any amount of data that you want. You can pull years worth of data, and you can do it quite frequently, and they'll just let you do it. And as this has been happening, I've had this running, I said, for 370 odd days. We're going to take a look and see what we have in our database. All right, just bear with me 1 second. Another really bad password here. That's really small. Let me make that bigger. Okay, so if we say /DT, how many of you are Postgres fans? Okay, fantastic. Postgres is so cool. I love Postgres. So we got a couple tables here that we are slurping data out of Yahoo Finance into. And we're just going to do a select count star on our history table and see, oh, that's not what was supposed to happen. Where's my SQL people? How do I count the number of rows in my database?
TSQL, I mean, from history, but I'm not sure.
I think that's what it is. There we go, okay. So it's doing its thing, it's counting. And one of the reasons I want to show you this is because there seems to be this misconceived notion that when you run a home lab or a cluster yourself, that it's just like really hard to do and it doesn't work very well. Or at least that's what my experience was when I first started out. So Yahoo has been generous enough to let us scrape 137 million rows of stock market data. And you can see that here through our 10.7 thousand total requests. And the history endpoint here actually takes quite a long time to return data, 637 milliseconds. Maybe it's rate limiting, maybe it's something else. And our observability dashboard will tell us here that everything is clicking along nicely. All right. We also have an uptime view here where we can see our the health of all of our services as well as the endpoints so that we know we can in fact generate some cows. All right, and that's the end of my talk. I hope you learned something new, saw some cool tools, something you want to take home and try on your own or deploy in your organization. Are there any questions?
If you have more details, you can go to the uptime.
Oh, really? Okay, yes, I can. So Uptime Kuma is a really cool service. Essentially, I have this running in my cluster next to my other applications. There's a configuration step that you can do with your Helm charts that say, these are the endpoints my services are running on. I want you to ping them this frequently. And they have a couple cool features where you can build like public-facing dashboards. So this is something I could serve up to my WordPress clients to come in and say, oh no, our cal function generator is down. I got a couple here that have pinged down more recently. You know, a lot of people may be familiar with the sites like Status Page and stuff like that, but honestly, something like this, Uptime Kuma, which is just, again, a Bitnami chart that I did very little base configuration on, it is a huge value to give that to your end users, whether it's internal or your customers, because whenever an AWS service or something goes down and I go to their down detector and it's like, there's nothing down, everything's running fine, it's like, but it's not working. This is a good source of truth here. If there's any health check that fails, it'll show up here. And you can also see some of this same information in something like OpenLens, where you have your services configured. Let me see here. Services. It'll tell you here if the health check fails, the status will become degraded, or it'll say it'll turn red and be upset with you. Good question, though. Sorry I don't have more details. The one takeaway for Uptime Kuma is put the configuration for your health endpoints in that values file, because if you need to redeploy it, it is a stateless application. So if the pod restarts, you lose some of that. But if you have it in your actual values file, you'd be good to go.
Is that monitoring? Because I know when you set up custom monitors through here, you can set up monitor Docker. There's a few different things and how it actually does the monitoring for that. So is that, the way you have it set up, because I haven't done it through like home charts or anything, but I've set it up like manually just for testing and playing around and being able to add stuff because it's open source. But like, so this is all ran through your CI/CD to set all this up. That's what it sounds like, right?
Correct. So the first time I did it, though, I did do the configuration manually. And when you go in, you have the opportunity to say, when you hit this endpoint, this is your expected result. And so if you have more complex things like an endpoint, for instance, that talks to a third-party service, you could set up a health check that would say, when this endpoint's hit, periodically, it's going to reach out to that service and come in. So you get to specify the endpoint as well as the expected response. And if you have more fine-grained error codes, like you're expecting like an unauthorized or something from an authentication endpoint, you can put that in there as well. I'm not an Uptime Kuma expert. A lot of the services I put in here, I just briefly read their docs page and then just kind of hacked it in there. And so sorry I don't have more specific information on it. Yeah, there's two types of developers. The ones that go and read all of the docs, and then they do a very good job. And then there's the other ones that read the first few lines that say, okay, this is how you download it and run it. And then they go figure it out on their own. And I am the latter. I'm not a very detailed-oriented person. I prefer to learn the hard way, see the error messages and have to go back to the docs and then figure it out. But then when those error messages pop up for other reasons, maybe I've already had to go down that path and see what was wrong with it. All right, so one more thing. Let's say that you have a disgruntled WordPress end user and they just want you to get rid of your deployment. They say take the site down, or maybe they didn't pay you and it's gone past the number of days. With the GitOps workflow, you can come in and you can just delete the files, which is just really, it's super simple. Come in, I'll just delete this file here, move it to the trash, and then I'll come down here, WordPress folder somewhere in here, right here. Move that one to the trash. Now, I could just wait for Argo CD to make those changes when it feels like it. And sometimes this is okay. If you have stateful applications, you really want to turn off the auto deployer because you may be kicking clients connections and things like that. So what we can come in and do is we can go to our root app here, which shows all of our different applications here that are tied into our Argo deployment. And we can say, okay, WordPress, delete that. Wants me to type it in. And there's some differences between foreground and background and non-cascading deletes. And then we can come over here, and it's already gone. So it's like it was never there. Oh, it's leaving now. Now, there is a little bit of a catch here. If you have an application like WordPress that needs to store stateful information in, say, a persistent volume, I have not given Argo CD the permission to delete volumes, because if I make a boo-boo or an accident on my deployment and I want to just delete the stateless part of it, I don't want it to wipe out my 137 million lines of Yahoo Finance data, right? So in order to fully get WordPress gone, we're going to have to come over to something like OpenLens. Or if you are a command line person, use kubectl, list your persistent volumes, and then you can delete them out of there. Let's see, where's storage? Persistent volume claims, WordPress. Delete. Delete. And those will be. I got a couple QR codes up here. This one is Epon Technologies. If you are in the East Coast or really anywhere in the country and you want to work for a really awesome company that does positive technology, I don't know what that actually means, but that's just what they say. We work on a lot of really difficult challenges. It's not staff hog, nothing wrong with staff hog, but we like to come to clients and solve their most pressing difficult challenges. And we do have a few open roles, so feel free to check out the site. And we have a DevOps practice, which I'm a part of, a cloud practice. We have a product engineering practice, a product management practice, and also a data practice, which right now is very busy trying to figure out all the AI stuff that's going on. And if I didn't mention AI at least once, and my boss saw this recording, he'd be very upset. And then this one over here is just my LinkedIn. Feel free to follow me. I'll follow you back. Sometimes I post about these types of things. And yeah, any other questions? Who wants to see some more ASCII art cows? Thank you very much. Oh. Let's go. Let me see. This one here? Yes. This is a tool called Open Lens. There is a paid version just called Lens, and it's essentially just a window into your control plane. So it's very similar to what you would have in a cloud provider like EKS or something. They would show you all the same stuff. Yep, Open Lens. They have a really awesome community. Some of the what do they call them? Extensions won't work on the open source version that they have for the paid version, but things like the resource map extension will work, so you can have this cool view and make things jiggle around. Yeah, I use this tool a lot. I do the whole command line thing, where you come in and say kubectl get pods, but this is just much quicker and easier,